Hi friends, good morning. Today we are going to discuss another section of differential equation, that is Legendre differential equation. Alright. So what is Legendre differential equation? Previous class we seen what is Hermite differential equation and what is Legendre differential equation. This is a new kind of higher order differential equation which is in the format, see this format, this differential equation. 1 minus x square into d square y by dx square minus 2x dy by dx plus ky equal to 0. Right. So this is the Legendre differential equation. Right. So the solution of this Legendre differential equation we known as Legendre Polynomial. Right. So how we solve this differential equation? To solve this differential equation, what we told, we consider solution as, for higher order differential equation solving, we consider a series solution, that is n is equal to 0 to infinity n x raised to n. Right. Now from this we find dy by dx, then d square y by dx square, and that values we substitute here and here, and y also substitute here. Right. Then we get a general equation, then we find the coefficients from that general equation, and then we substitute and we finalize the solution. That is the method we have seen, we done also. Right. Now we are not focusing to derive the solution, we need the direct solution. What is the solution of this differential equation? Right. So let us go to that. See, so this is the solution of differential equation. Right. So this is the solution. Right. This solution is known as Legendre polynomial. So when we solve that differential equation, what we get, this is the differential equation. Right. But from this we need the values of p0 of x, p1 of x, p2 of x, p3 of x, etc. Right. So at least p0, p1, p2 you should have to by heart. Right. For the examination point of view. Right. We can see what is p0, p1 we can solve. See what is p0. p0 of x means, here the solution is 1 by 2 raised to n r is equal to 0 to greatest integer n by 2 minus 1 raised to r 2n minus 2r all factorial r factorial n minus r factorial n minus 2r factorial x raised to n minus 2r. Right. So we need p0 of x means we put n as 0. Right. N we put 0. Then put r value. R value has r0 to, here n is you give 0 means 0 by 2. Then r has only one value, 0 to 0. So n r is 0, n is 0. Then substitute 1 by 2 raised to 0 minus 1 raised to 0. This is 0 minus 0, again 0 factorial. Here also 0 factorial. And here also 0 minus 0 factorial. And here also 0 minus 2 into 0, that is 0 minus 0 factorial, x raised to 0 minus 0. Then here is this is 1 by 1, this is 1, this is 1, 1, x raised to 0 also 1, then answer is 1. Then what is p0 of x value? p0 of x value is 1. Right. Now let us solve a p1 of x. Right. What is p1 of x? p1 of x is equal to, here you put n is equal to 1, then 1 by 2 raised to 1, n by 2. That means greatest integer of 1 by 2 what? That is equal to, again that value is 0. Greatest integer of 0 is 0. Greatest integer of 0.9 also 0. Up to 0.9 its value. Greatest integer of 0.1, 0.5, 0.3, 0.2, everything is 0. Right. Now 1 by, this is sigma, so we have 1 by 2 raised to 1 sigma r is equal to 0 to 0. That means r has one value only here also. Then that is 0. Then minus 1 raised to r, first n value I am putting, n is here 1 only. Right. Then 2 minus 2r factorial. Right. That is r factorial, 1 minus r factorial, 1 minus 2r factorial. Right. X raised to 1 minus 2r. Right. Now put r value, that is 1 by 2 into r value you put means 0 means here 1. Right. Here 1, here 2 minus 0 factorial, that is 2 factorial, that is 2. right? Here r factorial, that is 0 factorial means 1. Here r is 1 factorial, r is 1 only, right? Here 1, 2 minus 2, I am sorry. See, we are finding p1 of x only, right? Then n is 1, okay, sorry, r is 0 only. R you put a 0, 0 factorial again 1, right? 1 minus 0 factorial again 1, 1 minus 0 factorial again 1, x raised to r is again 0, x raised to 1, right? This 2 cancel, x, right? So what is p1 of x? p0 of x 1, p1 of x x. Similarly, if you solve p2 of x, right, you can solve, see here you give p2 of x means n2, then that is 1, then r has 2 value, first put 0, then sigma only, plus put 1 also, then you get a 1 by 2 into 3x square minus 1, right? This is the p2 of x value, right? So p1 of x, what is p0 of x? That is 1. What is p1 of x? That is x, right? And so on. So at least these 3 value you by heart, right? Now let us go to the different values. See, so these are the values we derived first 3 value. So up to this you by heart, right? But this also you remember, right? p3 of x, right? This is p4 of x, this is p5 of x, right? Now look here, what is p1 of 0? p1 of 0 is what? Put x, instead of x you put 0 means 0. Now what is p3 of 0? p3 of 0 means here 0, answer is 0. What is p5 of 0? See, p5 of 0, here x, here x, here x, all x replace with 0. What we get? 0. Generally p2n plus 1 of 0 is what? 0, right? 1, 3, 5, odd Legendre polynomial, p1, p3, p5 of 0, always 0, right? But p0 of x1, p2 of 0 is not 0, that is 1 by 2, minus 1 by 2 only. Here put 0 means you get minus 1 by 2 only, right? So that you remember. Now these values also you remember, right? Next, see, graphical representation, right? Graphical representation. What is p0 of x we seen? 1. What is p1 of x we seen? X. What is p2 of x we seen? 1 by, what is 1 by 2 into 3x square minus 1, right? Now look, so p0 of x is equal to 1, you at this is pn of x, right? This is our x value. Now here only minus 1.501, so one straight line at 1 you can see, that is p0 of x. p0 value, pn of x value is a constant, that is 1, right? See, x is equal to y is equal to x, what? S line, right? This is actually p1 of x, right? p1 of x is equal to x, right? Now this is a p2 of x is a quadratic term, then that is definitely by quadratic term there is a parabola, right? This parabola is in, right? This is representing p2 of x, right? Now similarly we can represent based on the nature of degree, we can represent the graphic, right? All right. So this about the graph, all right. Now generating function, right? So generating function is coefficient of t raised to n in 1 minus 2tx plus t square all raised to minus 1 by 2. See, you expand this using binomial theorem, we can expand this 1 plus x all raised to n. Using that formula we can expand this. Then what is pn? If you find t raised to 0 coefficient, you get p0 of x. In this expansion, t raised to 1 coefficient you find, you get p1 of x, right? t raised to 2 coefficient, right, coefficient of t square, what is p2 of x. Where you have to find this coefficient? In the expansion of this, right. So let us verify that. See, we can go to a board, right. See, look here, coefficient of t raised to n in the expression 1 minus 2tx plus t square all raised to minus 1 by 2, that is Pn of x, alright. See, now this I am expanding, right, this I can write as, here I am taking one negative outside, right, one negative outside I am taking, alright. So this negative minus of 2tx minus t square, right, all raised to minus 1 by 2. Now this I can write as 1 minus, see here you can write as 1 plus x all raised to n format, but here minus x only, right. So plus minus of this, right. See, look here, what is this expansion? 1 plus nx into, see, 1 plus nx plus n into n minus 1 into 1 into 2 into x square plus etc. This only binomial series expansion, right. So here, so 1 plus, right, what is n minus 1 by 2 into what is our x? This only, right. So 1 by 2 into nx plus n into, that is minus 1 by 2 into n minus 1, minus 1 by 2, minus 1 by 2 minus 1 what, minus 3 by 2 divided by 1 into 2, right, divided by 1 into 2 into our x square, that is this square, that is 2tx minus t square whole square. Now expand this 1 plus, right, this multiplying tx, this multiplying here minus 1 by 2 t square, here this is 3 by 4 into 2, that is 3 by 8 minus minus plus, and this is a minus b whole square, a square minus 2ab plus b square. Now this 1 I can write as, say, this 1 I can write as 1 into t raised to 0, right, and this xt, right, and this term, then minus t square by 2, multiply this, then minus 3 by 2 t square x square, here this 4 8 cancel, then minus 3 by 2 x t cube and so on, right. Now look here, what is the coefficient of t0? That is 1, that is p0 of x 1, right, we have already derived a p0 of x value 1. Now what is the coefficient of t raised to 1? That is x, that only p1 of x, x. Now p2 of x, what is coefficient of t square? Here coefficient of t square is minus 1 by 2, minus 1 by 2. Here also coefficient of t square what? 3 by 2 x square, 3 by 2 x square. Now you take 1 by 2 from this out, that is 3x square minus 1. Then this only we studied p2 of x. We studied p0 of x is equal to 1, p1 of x is equal to x, and p2 of x is equal to 1 by 2 into 3x square minus 1, alright. So this is the generating function, means when you expand this using binomial theorem, the coefficient of t raised to n, you get a Pn of x, right, alright, alright. Now let us go to main board, right. See, so this is about a generating function, alright. Now Rodriguez formula, right, Rodriguez formula, that means you can write Pn of x. So here, sorry, n is there, Pn of x is equal to 1 by 2 raised to n, n factorial, d raised to n, dx raised to n, x raised to x square minus 1 whole raised to, x square minus 1 whole raised to n, right. So to find p0 of x, what you have to do, put n is equal to 1, then n is equal to 0, then 2 raised to 0, 0 factorial, d raised to 0, dx raised to 0 into x square minus 1 whole raised to 0 means everything 0, that means this is 1. Let us see p1 of x, right, p1 of x, what, 1 by 2 into 1 factorial into d by dx, right, n1 n1, x square minus 1 whole raised to 1, right, that is 1 by 2 into d by dx of x square minus 1 what, 2x, that is x. It's also we seen, alright. See p1 of x, right, p1 of x we seen x only, p0 of x we seen 1 only. Similarly p2 of x you find, you get 1 by 2 into 3x square minus 1. So this value, this is known as right, Rodriguez formula, right, Rodriguez formula, alright. Now see orthogonality relation, orthogonality relation of Legendre polynomial. So, see this, that says minus 1 to 1 p L of x into p m of x dx is equal to 0 if L not equal to m, and it is 2 by 2L plus 1 if L is equal to m, right, alright. So another version is given here, Pn of x, Pm of x is equal to, this is second part, this only given. If L is equal to m means you can put a Dirac delta function, that means L is equal to m means this delta nm value is 1. If L not equal to m means its value 0, right. Okay, let us verify this, alright. See, suppose let us check the value, integral LHS I am taking. Okay, LHS I am taking p minus 1 to 1, say here p1 of x you are taking, here m, so L you taken 1, right, this L I am taking 1, m I am taking 0, then p0 of x dx, right. Here what is the condition? L not equal to m, see this is 0, L is equal, L not equal to m. Then let us check it whether we are getting 0 or not, right. If 0 getting, this part is correct, right. What is p minus 1 to 1, what is p1 of x, x, what is p0 of x, 1 dx. Now integrating this, what, x dx on integration, x square by 2, limit is minus 1 to 1, that is 1 square by 2 minus 1 square by 2, that is 1 by 2, right, minus 1 by 2, that is equal to 0, and correct only, right. So orthogonality relation is proved, right. Now second part, see second part also we can check. See L is equal to m, suppose I am giving L is equal to 1, m is equal to 1, both I am giving 1, right, both I am giving 1 means what happened? See minus 1 1, here p1 of x, LHS I am finding p1 of x into p1 of x dx, right, that is integral minus 1 to 1, p1 of x, what, p1 of x is equal to x, again p1 of x x dx, that is integral minus 1 to 1 x square dx, that is integral minus 1 to 1 x cube, sorry, we can integrate x square dx on integration x cube by 3, we can give limit minus 1 to 1, then 1 cube, that is 1 by 3 minus 1 cube, that is again minus 1 by 3, and that is 2 by 3, right. Now see, suppose you are putting, what is L value you are taken 1 only, then 2 into L value 1 plus 1 what, 2 by 3, the same 2 by 3 we are getting, right. So this orthogonality relation is working out. See, and n is equal to m, n is equal, suppose I am writing this orthogonality relation in this format, if n is equal to m, see here n you given 1, m you given 1, Dirac delta 1 1, Dirac delta 1 1 1 only, any m is equal to n time Dirac delta value what, 1, then 2 by 2L plus 1, this value come. So this is another representation of this using Dirac delta symbol, alright. Alright. Now recurrence relations, right. This also we can prove. See, suppose you put a n is equal to 1, right, then what, here this is one of the recurrence relation, this is another recurrence relations. Pn of x, see Pn equal to P dash n plus 1 minus 2x P dash n plus P dash n minus 1, right. Now put n is equal to 1 here, right. So n is equal to 1 means P1 is equal to P dash 2, right, minus 2x into P dash 1 plus P dash 1 minus 1, 0. Now LHS is what? P of 1, right, P1 value what? P1 is x, right, P1 is equal to x, LHS is equal to P1 of x, that is x. Now RHS what? RHS is equal to P2 dash, that is d by dx of half into 3x square minus 1, right, this only P2 of x value, it's a differential, minus 2x into P1 dash, that is d by dx of P1 value is x, right, P dash of 0, right, P dash of 0, here P dash of 0, P dash of n minus 1, what is P0? P0 is 1 only, then again differentiating means 0 only, right. Alright, now we can write this as 1 by 2 into, this is what, 6x minus 2x, right, then 3x minus 2x what, x only, right, that only we got, then LHS is equal to RHS, right. Alright, now P2n of 0, okay, P2n of 0 and see here P2n of 0. P2n of 0 is minus 1 raised to n 2n factorial 2 raised to 2n n factorial. Okay, put n is equal to 1. Okay, either side put n is equal to 1. Then LHS what? LHS is equal to P2 of 0. That is 1 by 2 into 3 into 0 square minus 1. What is that? Minus 1 by 2, right? See, 3x half into 3x square minus 1 is equal to P2, right? P2 of 0 means x replaced with 0, 1 minus 1 by 2, right? Now what is RHS? RHS is equal to minus 1 raised to P2, then n is equal to what? 2. Here 2 into 2, 4 factorial divided by 2 into 2, 2 raised to 4, am I right? 2 raised to 4 into n factorial is what? 2 factorial, right, P2 of 0. Here 2 raised to 2n, 2 factorial, 2 into 2, that is 4 factorial minus 1 raised to 2. So this is equal to what? So sorry, here P2 of 0, what we have to give? N is equal to 1 only, not right, then only P2 of 0 you get. Here you have to put 1, right, here you have to 2 into 1, then 2 factorial, here 2 raised to 2n, n we taken 1, then 2 square, right, here n you taken 1, then 1 factorial, right, then here minus 1 raised to 1, minus 1, 2 factorial 2, 2 square 4 into 1, that is minus 1 by 2. Then LHS is equal to RHS, right. Now P2n plus 1 is 0, that is generally starting onwards we discussed it, because P1 of x what? Right, P1 of x all, let us go back to here, any odd power you take, see, see, P1 of x what? X. So let me take a pen. P okay, here you take. See, P1 of x is x, P3 of x this one, P5 of x this. Here all you put x 0, then P1 of 0 means 0 only. P3 of x, P3 of 0 you put here 0, here 0 means 0 only. P5 of x what? Here 0, here 0, here 0 means 0 only. What does it mean? All odd Legendre polynomial of 0 is 0. That means P of 2n plus 1 of 0 is what? 0. Right. So that only that orthogonality relation. See, let us go to that particular section. Yes, this is P2n plus 1, right. P2n plus 1 of 0, right. Here, 1 0 is missing. P2n plus 1 of 0 is what? 0. Alright? Alright. Now, let us go to some problems. Alright? See, f of x is equal to one function given 1 plus 5x plus 3x square, right. The Legendre polynomials P0 of x1, P1 of x, right, P1 of x is equal to x and P2 of x is equal to 1 by 2 into 3x square minus 1. Sometimes these values are given here. Most of the problem they won't give these values. You have to, up to 3 value you have to by heart it. As this f of x is equal to sigma n Cn Pn of the value of C0 is. See what they are telling, f of x you can represent as sigma n Cn Pn of x, right. That means we can represent like this, like that. See, first you put C0, right, Z0, P0, right, P0 of x, then C1, P1 of x plus C2, P2 of x. Up to this only we required. Why? Because up to x square only function. P2 of x only x square, right. Now, if I represent like this, what is the value of C0? That only the question, right. So, what is our function? F of x is equal to, what is that? 1 plus 5x plus 3x square, right. So, that is f of x is equal to, what is 1? 1 is P0 of x value. P0 of x value is 1 plus 5 into, what is x? X is P1 of x plus 3 into, what is x square? See, find x square from it. Suppose from this value, you find 2 P2 of x equal to 3x square minus 1. Then 2 P2 of x plus 1 divided by 3 is equal to what? X square. That you substitute here. 2 P2 of x plus 1, right, divided by 3. Then this 3 cancel. Then f of x is equal to P0 of x plus, here we have one value, that is 2 P2 of x, right, 2 P2 of x, 2 P2 of x, right, here 5 P1 of x, and here 1 is you can write as P0 of x, P0 of x, then P0 of x plus P0 of x what? 2 P0 of x plus, here we have 5 P1 of x, here we have 2 P2 of x. Now, as per the summation, this is the series. Then instead of C0, what came here? 2. Then what is option? 2 only. Alright? Alright. So, option C is correct. Right. Now, let us come to another problem. P5 of 0. Right. P5 definitely, directly you can write it. Right. What we studied? P2n plus 1 of 0 means that is 0. This is a orthogonality relation we studied. Right. Now, that P5, 5 is 2n plus 1 format. You put n is equal to 2 means 5 come. So, this odd come here means it's P2n plus 1 of 0 is what? 0. Right. So, this is about this section, and coming section we discuss about a Bessel differential equation. Right. Bessel differential equation is very important regarding the quantum mechanical hydrogen atom problem solving. Right. All right. Thank you.